Swayam Prabha. Digital India. Educated India.
Title of this today's lecture is on dependency structure matrix. In the last class I have introduced and I gave you a slight background on what is design management, information, what is information and so on. So, these with the help of this technique called DSM, you will understand how to also go ahead in finding out scheduling aspects in DSM. So, let us move on. The contents, in the last class I have also shown you what are the basic operations in DSM, like formation of DSM, partitioning of DSM, then tiering processes and iteration modeling. So, in that the first two operation, basically the formation and partitioning, is what we are going to see in today's lecture. Just to brush up your minds. So, this is a formation of DSM. I have taken the same example as shown in the last class. This is the partitioning, wherein for this particular example I am getting one block, okay, and then once you do the tiering process, in the sense identifying the tire marks or place for assuming, then you get the tiering block like this, and once you finish, then you have to again do the repartitioning and you will see this block. So, primarily the three operations are here. This is operation number 1, formation. This is operation number 2, which is a partitioning. The third one is tiering. Tiering always goes along with the repartitioning, and then the next step is primarily the iteration modeling. So, now unless you stop with the 3 steps, you are only identifying the sequence outside the block. With the partitioning, you are identifying the sequence outside the block, and you are also aware of where are the block formations. Okay. In the tiering and repartitioning, what you are going to do is, you are not touching outside the blocks, you are only going to operate within the block. So, within the block, where are the tire marks and what is my sequence within the block and what is my process of execution. That is what you are going to see in tiering. Now, the question that comes to your mind is there a better sequence than this, for example, CAEF and then BD. So, primarily with the CAEF, is there another alternate sequence? So, primarily 4 factorial combination sequences are possible for the 4 activities within the block. Now, so accordingly you have like 16 combinations are possible. Okay. So, one way is to go ahead in evaluating all the 16 combinations and then seeing what is the best duration, or other way is primarily to do the iteration modeling. Okay. So, how to test the performance of the sequence? The only one method is add duration along the diagonals and then find out the duration for this project or for the block, whatever suits you well, and then you have to find what is the how much of rework has happened, how much of waiting time was there, and what is happening, which activity is taking more time in the rework. So, you can analyze with the help of iteration modeling. That is a phase number 4 or operation number 4. Okay. So, now as I told you, we are going to see with the formation of DSM. So, building or creating a DSM, in other words we call it as a formation of DSM. I gave a very simple steps. This is not, this is like it can go through for any way with which you are creating a DSM, okay, which also I will little bit I will explain later. So, first step is to define the scope of the project. Okay. So, for example, whatever project you want to take, how many other disciplines are there, how many other components are there, you choose accordingly and you define what is the scope of the present project. Okay. Then you decompose the entire project into various elements as possible. So, you can stop at level 1, you can stop at level 2. So, the common method of decomposition we have seen in the earlier classes is WBS. You can go through the same WBS methodology in order to decompose the system, and you can stop at level 1, 2, 3 wherever you want, you can still do the same and you can build the DSM. I will show you that also in today's class with various levels of the DSM formation. Then identify the list of elements. Elements is a common name which is given for either you want to do component, teams, activities, parameters, whatever. Okay. So, when I am decomposing an project, I may land up in so many different sub levels which we have shown in the last class. So, it can be components, teams, activities, deliverables, parameters, etc. So, you can stop at any one place, and accordingly you can create that particular type of a DSM. So, if you stop at activity DSM, activity level, you can form an activity DSM. If you stop at component level, you can form a component DSM. So, there are so many types of DSMs also available. Okay. So, list the elements in the same order in the rows and columns. So, accordingly what you have to do is you have to identify the elements. The elements is generic name given for components, teams, parameters and so on. So, if you want to do at activities, then list out all the activities in the same order in rows and columns, so that you are getting the skeleton DSM. Skeleton DSM is a blank DSM with just the rows and columns identified and no relationships are identified. Okay, that is primarily called skeleton structure. Then collect data on the relationship. Once you have listed out all the rows and columns, the next step is finding out the relationship between those identified rows and columns. Okay. For that we are suggesting a method with which we have worked out, and that you may follow, or there are several other methods with which you can also build or define the relationships. Okay. Then check for the validity. Once you have done all the X marks, it does not mean it is fully complete. Go to the experts and see whether there is still any unidentified relationship, or whether there is a wrong identified relationship, something is missing and so on, that you have to cross check. And once you are very clear that you have done everything perfectly fine, then you can really go with assurance that the matrix formation is fully complete. So, this is a very basic steps with which you can create a DSM. Now, let us go through the steps in detail with an example. The first example which I have taken here is IDCT, which is induced draft cooling tower. Okay. This example, it consists of 4 disciplines such as civil, mechanical, electrical and instrumentation. So, there are 4 disciplines for the particular scope of this IDCT project. Okay. So, that is the reason why I have chosen this. Now, the cross sectional details of this drive of this IDCT is given here, of the induced draft cooling tower is given here. I think many of you know what is a cooling tower. It is primarily a part of a power plant project in order to cool the water which comes from the turbines. Okay. So, now what are the levels? So, primarily it has several levels. One is drive assembly, drift eliminator, water distribution, fill level, sill level, cold water basin, foundations and so on. Okay. So, the water is generally coming through the hot water basins, and it moves in through the drift eliminators and the water distribution lets. Okay. What happens here is the fans and the drift eliminators prevent the water particles from going outside. Okay. So, this is primarily the hot water basin with which the water is falling in, and in the fill level there are the cooling medium, okay, which cools the water, and once the water is falling on at a very large level, naturally the water gets contact in touch with the air and the water gets cooled, and then it starts going into the cold water basin, where the cold water is collected again for recirculation of the water process. Okay. This is primarily the mechanism with which the IDCT works. Now, for the particular example in formation of a DSM, we are going to see only the drive assembly level, which is a topmost level. Okay. So, little more a zoom in view on the drive assembly level to show the sectional details. If you see here, so this is primarily the, let me use my pen. Okay. So, this is primarily the hatch in the deck for all the operations to happen, and these are all the handrails as shown here. This is a ring beam, this is a fan stack. Fan stack is primarily the cover to the fans. Okay. Then we have the fan and the fan blades, then this is a gearbox mechanism which is here, and we have the fan stack door for people to move out and inspections and so on. Then this is a motor, this is a pedestal for the motor, and this completely you have a fan stack, a fan deck slab for people to move around. So, here if you see, there are all people coming in, you need electrical wires and cables and so on in order to move the fan, operate the fan, motor and gearboxes. civil work is already there. These instruments are primarily the mechanical equipments, and we also have so many instruments here to check the noise on the fan, to check the vibration of the gearboxes and so on. So, there are other instrumentation assemblies are also there. Okay. So, now what do I do? As I told you, first is you have to get the list of elements. Okay. The project is defined, I am going to work only on drive assembly level, that is very clear. Then this decomposition level, decomposition I am going to use the WBS structure only. So, first is level, that is how the project they are very comfortable in working. So, I am also going to show in the same way. So, drive assembly level, that is the level with which it gets decomposed. Then you have mechanical team, civil team, instrumentation team and electrical team. There are 4 teams in the particular project, and you know what are the components here: fan, motor, gearbox, drive shaft, accessories. In the mechanical side, in drive for civil discipline, there are accessories, fan deck slab, fan stack and so on. In instrumentation, level switch, accessories, vibration monitoring systems, electrical again, accessories, illumination systems and the earthing and lightning system. Okay. These are all the components. So, I have one activity identified for all the components, never it is one, but in this case it happened to be one. So, I have fan design, motor design, gearbox design, drive shaft design, details of equipment handling system, details of removable walkway, handrails and trolley, details of ladders, doors and hatches. Primarily the layout and all these has to be shown. So, these are all the list of activities I have for the mechanical discipline, okay, in the drive assembly alone. In civil work, details of insert plates, anchor bolts for all the cable trays and so on. Then details and design and details of slabs, grid beams, pedestals at fan deck level. Then design of fan stack and ring beams. So, these are all the activities in the civil discipline. Then for instrumentation, data sheet of level switch, instrument location and cable routes, data sheet for vibration monitoring system. So, these are all the activities we have in the instrumentation. For electrical, cable trays and trench layout, illumination systems or lighting system of the cooling tower, earthing details and lightning protection. So, accordingly we have almost like 16 activities in the entire drive assembly level. Okay. Since it is very big an activity list, I have given an activity ID for the same starting from D, because it is a drive assembly level. So, I have used D as a code. So, D stands for drive assembly and A, B, C, D are all the list of activities. Okay. So, I have used simple WBS for the decomposition. The next is how do I, so with this I can easily get my skeleton DSM and I can fill in my relationships. But what happens is, with the way you wrongly identify a relationship, or you put the relationship in a different place or something, or you miss out identifying a relationship, you get a different result altogether. In order to avoid that, we are using a new methodology. So, this methodology is nothing but multiplying 2 matrices so that I get a DSM. Okay. So, these 2 matrices are variable DSMs, or we call it as a DMM. DMM stands for domain mapping matrix. Okay. So, the DMM is primarily the domain mapping matrix, which stands for, which actually has a rectangular shape, and it is not a square, wherein it maps relationships between 2 entities. So, one can be an, as here it is primarily a list of activities on the rows, and along the columns I am having a list of parameters. Okay. So, with this you can form all the relationships, and what happens here, any activity will have a set of outputs at the end of the activity execution, and activities also need inputs from other activities. Okay. So, every activity needs a list of inputs. So, when you multiply these two, you will actually get an activity DSM. That is what is the main purpose behind, and logical way of doing this also I will show you right now. Manually also you can do. You make this as binary matrix and multiply the 2 matrices, you will obviously get another matrix. Okay. So, for example, let me read through. So, fan design, so this is for output parameters and this is for input parameters. Fan design can release fan power calculations, which is required by motor design and gearbox design, and fan design can release hub and seal disc diameter, which is required for design of ladders, doors and hatches. So, fan design also releases fan diameter and tip clearance, which is required for numeration and RC details of fan stack and ring beams. So, like this you have to go through this. So, what happens is, so I am having a DSM like this. So, these are all my activities. I wanted to form an activity DSM. So, DA, DB, DC and so on. As I told you, for beginners it is better that you write what is the X really representing for till you go for validation and check for the whole flow. Once the whole flow is really defined, then you can cut off all the values and you can replace it to X marks, which is very easy to do. For example, so DA is releasing fan power calculations, which is required for motor design and gearbox design. So, what I have written here is DA to DB, what is the X actually there? It is a fan power calculations. DA to DC, what is the X really representing? It is a fan power calculations. Now, DA also releases hub and seal disc diameter, which is required for DG, which is the details of ladders, doors and hatches. So, same way DA to DG, hub and seal disc diameter is the parameter which is traversing between from DA to DG. Now, same way D fan design also releases fan diameter tip clearance, which is required for activity DJ, which is the numeration and RC details of fan stack and ring beams. So, what happens is DA to DG, primarily the fan diameter and tip clearance is what is the input which is traveling from the one activity to the other activity. So, same way we can travel through the entire activity DSM. Motor design releases motor rating, which is required for gearbox design, which is shown here. Now, this motor design also releases selection and sizing of motor, which is required for activity DI, which is the layout, numeration and details. So, here you have written here selection and sizing of motor. The gearbox design releases an output called selection and sizing of gearbox. The selection and sizing of gearbox is actually required for motor design, it is required for details of ladders, doors and hatches, it is also required for layout, numeration. So, it is required for 3 activities. So, selection and sizing of gearbox is required for DB, DG and DI. Now, the details of ladders, doors and hatches releases information on fan stack door details, which is actually required for activity DJ, which is the numeration and RC details of fan stack and ring beams. Okay. So, which is written here and accordingly the entire matrix is filled. So, this is how the activity DSM is filled. So, now I have got the same matrix, I have shown it here. Now, once you take it to validation, it is easy for somebody to go through. Okay, fan power calculations, this is required for here. So, it is easy for somebody to validate this matrix, and once the matrix is validated, then you replace it to X marks for your further calculations. Okay. So, now formation of activity DSM is really done. Okay. So, so far we started up with defining the scope of the project, then decomposing the project, that I have shown you the levels, okay, teams, components, then activity list, and then use variable DSMs, or the other name I can say is a DMM, which is a domain mapping matrix, and I am having a rectangular matrix, 2 rectangular matrix. Then primarily you have to multiply if you want to mechanically do, or you can go through the logic also, I have explained you that. You do that and then you are getting this matrix, convert into X marks so that you will get the activity DSM. Okay. So, which is what I have shown. Now, in this define the scope, define the decompose the system, in this decompose the system I can stop at various levels. In the previous example I have stopped at activity levels. Now, in the next example I will show you how to form a team DSM or a component DSM using the same methodology. Now, whatever you have stopped, you wanted to form the type of DSM, you can decompose the elements in the same way, list the elements in the same order, and you can still collect data on relationship, and you can still go ahead with the matrix formation. Now, I am going to take the next example. The next example is on interceptor sewer. Okay. This is a very simple example. I have shown this example in different form in the earlier classes. Primarily I have 4 components. Okay, I am going to work at component level. So, I am only showing the components. I have intercepting chamber, manholes, and sewage pumping stations. Lifting stations are also there, but I am not showing right now in this particular work. And this red line is primarily the intercepting sewer. Okay. Now, for the particular manhole component alone, I am going to show the team DSM formation. Okay. So, now these are the 3 teams T1, T2 and T3, and these are primarily the drawings D1 and D2 and D3 are the 3 drawings. Okay. If you see here, the identification is given in the legend here. Topological survey team is T1, geotechnical investigation team is T2, structural design team is a T3, and I have details on deliverables. So, D1 is location details of manholes, D2 is GA of manholes, GA stands for general arrangement, and D3 is design of manholes. Okay. So, this is the first DMM which I have formed with output deliverables. So, T3 is actually giving 2 deliverables, which is D1 and D2. Okay. Now, these deliverables are required, there are several deliverables required for the teams. Okay. Let us see on the input deliverables. So, D1 is required for T1 and T2, D3 is required for T2 and T3. Okay. So, now if you see here, I am going to form a team DSM. Now, I have not used all my X marks here, I will tell you that also later. So, T3 is releasing an input call, releasing an output called D1, which is required by T1 and T2. So, T3 is actually having a dependency relationship on information with T1 and T2. Okay. So, this DSM is done. Okay. So, I have used only the few relationships here, other relationships I have not used. So, which is what I said, when you actually know, avoid this X mark and then write properly what is it, like I showed you in the last example, it is easy for you to map the complete or go through the complete flow of the process, design process, and map all the relationships. Okay. And the other problem that happened here is, I have used a small example, so many of the relationships got missed out. When you are really building up a complete design example, all relationships can be easily be identified and shown. Okay. But this purpose of this example is to only show the how to form a component team DSM for the manhole component. Okay. Same manhole component, how to form a deliverable DSM. Okay. So, I am going to use a DMM again, but there is a list of deliverables and output parameters. So, now these are the deliverables, same deliverables I have, location details of manholes, general arrangement of manholes, design of manholes, and I have identified 8 parameters for this, all these 3 deliverables. Pipe diameter is P1, P2 is diameter of chamber, P3 is diameter of access, P4 is height of the chamber, P5 is grade of concrete, P6 is type of reinforcement, P7 is coefficient of earth pressure, and P8 is dead load. So, I have all these parameters, same logic still works good. So, I have list of deliverables, I have list of parameters here. So, these are all my X marks identified for the parameters, same way for the input parameters. So, now what happens here is, I am going to use for my D2 is actually releasing P1, which is required for D1, which is identified here. So, D2 is releasing P1, which is required for D1, which is identified here. Okay. So, now D3 is releasing P8, which is required for D2, which is identified here. Okay. Other parameters did not come within the scope, but the idea is to convey to you. So, the logic for formation, if you want to identify a complete DSM, is go through decomposition, WBS will still hold good for you, and then formation of DSM in so with the help of WBS you can identify all these levels. Okay, it can be level 1, level 2, whatever it is, drive assembly level, or you can go through team level or component level, activity level. I have shown you several cases right now. So, you can stop at any level. WBS will help you to identify only this. Once this is identified, for identifying X marks, you can multiply the variable matrices and you will still get the relationships identified. Then go through with the experts, see whether everything has been identified, and then you have to validate your matrix formation. Okay. Because if you identify a wrong matrix, then obviously your results are all going to fail very bad. Okay. So, that you have to take care. So, that is all on about matrix formation. So, now the next step is partitioning. Okay. So, as I told you, first step or first operation in your matrix operation is formation of activity DSM. Once the matrix has been formed, the next step is primarily the partitioning processes. So, what is partitioning? I think I gave a quick info earlier also while I introduced the lecture. So, partitioning helps you to identify what is the relationship of the entire project, and wherein there are no interdependencies or cycles, or let me put it in another way. So, when the project has independent and dependent activities, those are all identified in the partitioning process, and wherever there are cycles or interdependencies, they are all grouped together as a block formation. So, my complete project, I will know what is a sequence of my independence and dependence, which are all collected together, and then I know where is my block formation happening. Okay. And the methodology also I will explain, which is a very simple method on matrix multiplication. I will show you that, and along with an example, so that you can follow me along with the example at various steps how the matrix gets changed. Okay. That is all is about the partitioning process. Partitioning never talks about relationship within the block, and also it never talks about sequence within the block. Okay. This A, C, E, F. So, I have shown here partitioning will not talk about this sequence. So, you have to go through the next step in really identifying what is the sequence there. Okay. So, let us now see the definition on partitioning. It is a process of reordering the DSM rows and columns. It can be component, it can be teams, it can be activities, it can be deliverables. Whatever you have identified, you are only going to reorder in such a way that the new DSM arrangement does not contain any feedback marks, or primarily you have to minimize it into a lower triangle. Okay. So, thus transforming the DSM into a lower triangular form. Okay. So, primarily I will be getting a lower triangular matrix. Okay. If I have only an independent and dependent relationships. Now, what happens is, if it is difficult to make a lower triangular matrix because of the interdependencies and cycles, attempts are primarily made in keeping those elements identified as a block formation. Okay. So, still there are methods which can make you to keep these x marks close to the diagonal, but partitioning never attempts on that. Okay. In doing so, only few elements will be involved in the cycle. So, try to minimize this formation itself, okay, identification of block itself. Now, what is the meaning of this block formation? That also you should know. So, this implies these four, suppose if these are all activities, these four activities have to be worked together till the completion. So, that because each of them reads input from each one of the other. Okay. For example, ACEF is primarily a block. Okay. What is the meaning of the block? The teams have to work closely together like this in order to finish the completion of the particular scope of the work. Okay. And then activity B and D. So, that is the meaning of the logical meaning of the partitioning block formation. Okay. Now, what is a partitioning flow process? Now, there are several methods for partitioning as given in the websites. Okay. If you go through the DSM website as such, you will see there are so many methods like path searching, matrix multiplications, or we have triangularization matrix. Like this, there are n number of methods available. Okay. So, for identifying the sequential, the parallel and sequential activities, topological sorting is the best way to do. And once you identify the topological sorting and identify that there is a big block, but I do not know what are all there within the block, then you have to choose one of the methods like path searching or matrix multiplication and so on. Okay. But it is not a straightforward method, you have to work in cycles. Primarily there is an iteration inside, which with the example, I have taken an example in such a way that it can cover all the problems which you have in the examples. Okay. So, within the cyclic process also I will explain properly. Okay. Now, partitioning flow process, there are primarily three broad items here. One is topological sorting, primarily to identify all my sequential and parallel activities. Then I do matrix multiplication. Matrix multiplication, or take off this concept and put path searching, can help you to identify or trace the cycles only. Once you have traced the cycles, then you have to group them into blocks, again repeat the process on topological sorting and matrix multiplication until you identify all the cycles and all the activities. okay, and at last you get the partitioning DSM. This is the overall flow on the partitioning process. Okay, now let us go through with the hypothetical example. So, for explaining this partitioning process, I have taken a hypothetical example. Okay, this is a generic A, B, C, D example. I have taken A till K as a simple example because I have to show all these n number of steps. So, I have taken little bit bigger example only. What is the first step as shown earlier? Check for x marks above the diagonal. Do I have x marks above the diagonal? Yes, I have lot of x marks above the diagonal, which implies this is not the right sequence for you to execute the whole block. Suppose if there are no x marks above the diagonal, so what it means is the matrix is already partitioned. Okay, already you know what is the best sequence to operate the entire flow. Okay, that will be very sure if you do not have any x marks above the diagonal, then directly you can go to the last step in saying the matrix has been already partitioned. Okay. Now, since I have x marks, so same example I have shown you in a smaller form on the top, so that you will follow the slides. Now, as I told you, once we have x marks above the diagonal, the first step is to do topological sorting. Okay. Topological sorting is the graph theory terminology or concept. So, what does it say? I have written very simpler steps for you. So, primarily you have to identify all empty rows and columns or rows and columns, okay, in order to identify the start and the last activities. Okay. So, when I am having a starting activity, obviously I will not have any x mark along the rows. So, that will be shown as an empty row, and when I am the last activity, then I do not need any I am not going to give any inputs to other activities. So, I may have empty columns, and but I may have lot of x marks along the rows. Okay. That is the meaning of topological, in order to identify the starting parallel activities and the last activities. Primarily the first activity, last activity I am going to trace out now with this method. Okay. So, first step is move all the empty rows and the corresponding columns to the top and left respectively, and omit those activities for further consideration. Okay. Now, let us go through this example. Where are the empty rows right now? Activity D has an empty row. So, there is a complete empty row here. Okay, there is nothing given in the activity D. So, what I am going to do is, so I have identified that activity D has an empty row. You can use Excel sheets for doing, or there are softwares also available which can help you to do the partitioning process. Okay. So, I have moved my activity D to the primarily to the top and left, because I have to pull out both my rows and columns accordingly outside. So, just cut off that row and a particular column and move to the top and push all the other activities, you will obviously get this matrix if you want to do manually. Otherwise, you can run a small VBA program and you can still go through the exercise. Okay. So, now what we have to do is omit those activities for further consideration. So, in the first step I have written move them to the top and left, and then do not include them in the further calculations. Okay. So, I have identified D as my first activity, and I am going to ignore this in my further analysis. Okay. Now, what you have to do, you can repeat the process of identifying empty rows again, or you can go to the other step as identifying empty columns, and you can swap this up and down. Okay. In this particular example, what I am going to do is, I am going to identify all the empty rows after omitting the activities, and at the end I am going to identify my empty columns, and this I am going to repeat it again and again. Okay. So, now let us see the next step. So, what I am going to do is, I am going to identify all other empty rows and rows also. Now, if you see, after omitting this activity, where are my empty rows? This activity D, E has completely no x marks along the rows. So, activity E is primarily my second activity in the list. Okay. So, D is giving inputs to activity E, but it is not the first activity, but it is a second activity. Okay. So, push the activity E next to activity D and then omit this from further consideration. Okay. Now, do I have any other empty rows? So, in this example I do not have any other empty rows. So, primarily I have finished my first step on move empty rows completely, which primarily has no, which primarily is primarily the starting activity or next sequential activities. Okay, I have identified all the first few start activities. Okay, after then the block starts and you are not aware of where the block is and so on. Okay, now I am going to move this. So, I am going to finish this step in cycles and then I am going to do this, but as I am telling you, if you want you can swap these two in order. You do this first, do this again, then you can do this. Primarily what I have done is I have finished all, this step is over now. I am going to go to the next step now. This is my last step. I have shown this picture in the top corner. Now, move all empty columns and corresponding row to the right and bottom respectively and omit those activities from further consideration. Okay. So, what are the activities that are empty? I have activity C is empty here. I have activity J also, which is completely empty. Okay. This looks like C and J are parallel activities, but they are in the last in the sequence. Okay. So, I can move C and J completely to the last. Now, what is the order of C and J? That is, there is no restriction here because both are empty, both are parallel activities. There is no worry if you want to place C first and J first, or you want to place J first and then C first. There is no problem at all. Okay, so now I have moved C and J to the last. So now what happens is I have identified D as my first activity, second is E activity. I have also identified there are two parallel activities in the last as C and J. Now again I have to repeat this process to check any other empty columns are there. So any other empty columns are there, it looks like there are no other empty columns. Okay. So this process I have to repeat in cycles, which is what I said. Okay. This has to go in cycles until completion. Now within this, now I have got a bigger block and all empty rows columns are identified. Okay. Only the start last activities are identified. Now you have to find out what is there within this particular stretch. Okay. Now what is the next step? So topological sorting process is over. Okay. Next step is matrix multiplication in identifying cycles. Okay. So now what you have to do, I have got this matrix. Now I am going to give a new name for this matrix. So this is primarily the active matrix, which implies the matrix for consideration is only this portion for you, because you know D is first activity, E is second activity, C and J are the last activities, that is known to you very well. Now your main botheration is to know what is the sequence within this. Okay. Now what you have to do is convert the active matrix into a binary matrix. Now this is my active matrix. Now how do I convert into binary? While explaining the types of DSM, I have told you this. So replace all these X marks as 1. If you are working on Excel, again it is very easy. Select for all these this particular cell. Okay, search for X and replace with 1, you will get all ones. Empty cells all, if you put 0, you will easily get a 0. Okay. So I have just converted all these into a binary matrix. Now I have my binary matrix. So this step is really over. Okay. So take out the active matrix and I have converted into binary and I have the binary matrix right now. Okay. Now what do? Raise the powers of the matrix. So this is my example. Okay. Raise the powers of the matrix until there occurs a non-zero entry along the diagonal anywhere before power n, or else stop at power n. Power n primarily I am using an alphabet which talks about the number of activities here. Okay. For example, in this case I have 7 activities. So I have to stop till power n, whatever happens, or well ahead of power n when I am able to get some non-zero along the diagonal. Okay. So I have raised, I have a binary matrix which I have shown you in the previous case. So I have done primarily one multiplication only, which we call it as a cycle of which we call it as power 2. Power 2 is the binary square. Okay. So I have done multiplying only once, and what happens is I identified a non-zero entry here. Okay. So this implies G is here, H is here and I here. If you are not very comfortable in identifying or tracing the loop, you have to do the tracing by go through the relationship and then identifying where is the real loops. Okay. Because I have got values as 2 also. This 2 implies this H is on 2 cycles. Okay. and G implies it is on one cycle and I implies it is available on one cycle. So, how does this relationship look? You can go through later after cross checking with the example. So, this is what is the tracing on the whole loop. So, this is primarily we call it as a overlapping cycles. So, H is primarily it is in the midway between G and I in the length of cycle of length 2. Okay, that is what we have identified in the matrix square or adjacency matrix raised to power 2. Okay. So, now what happens once you have identified the activities corresponding to the non-zero entry, have identified it G, H, I are in those activities, check for the individual loops, that also I have done. Sometimes I may get values here, there, this may be in some other block, this need not always be together in one block only, it can be 2-3 blocks of cycle of length 2 can also happen. So, you have to check for individual loops. The one way to do, again I am repeating, go through with the original example and trace for the cycle, so that you will get the cycle. Okay. Then what you should do, collapse or merge those activities on the loop into one. So, what I have done, G, H, I, since it is all in one group only, I have merged the G, H, I into one block. So, I have made it as one and I have merged the relationships also into one. Okay. So, I have now the new matrix which is like this. Okay. Now, what you have to do, again you may have, so let me also tell you what is the problem if I have not stopped at this step. Okay. You should also, now you may have a question, why should I go through this merging and this process again and again? Why can't I go till power n directly, okay, and then identify all the bigger cycles or loops? You will not be able to identify. For example, I will tell you, this is raised to power 2, okay. The same example I am raising it to power 3, I am getting A, B, F as like this and then H, I, K as something. So, the minute you go on without merging the first formed loop, okay. So, the first time you are getting a non-zero entry, you have to stop there and then you have to identify the cycle and then proceed after merging only. If you do not do, there is no use in the matrix, because these loops will give new values and then you will not be able to identify properly the loops. Okay. So, that is what I wanted to show you on what happens when you raise it on power 3. You can cross check with any example later. Okay. So, now let us move on. So, what you have to do after this? So, once you identified the loops, you got a smaller block within the bigger group, okay, and what you have to do is you have to again do the topological sorting, okay. So, which is what I have written here. So, merge them into single activity, then repeat the topological sorting, then check for the X marks above the diagonal. Topological sorting generally talks about that only. Highlight the condensed loops as blocks if there is nothing else available. Okay. Now, this also goes on in cycle. Let me show you with the example, then you will understand better. The same example as shown in the previous slide, I have taken it up here. Now, what you have to do, there are X marks above the diagonal, and what about topological sorting? When I do topological sorting, I do not have empty rows or columns, okay, because you merged a block completely into one. You may also get empty rows and columns now, okay. There may be small blocks within this block also, you have to identify everything, okay. So, that you will identify when you are doing the topological sorting again and again. In this case, that nothing happened, okay, because there is no empty rows or columns as seen in the example. Then what you have to do, you have to identify the remaining cycles or loops, okay. So, I am converting into binary, same process. Okay, then when I raised it to power 2, identified that there is a block of cycle length 2. So, F is dependent on GHI and GHI is dependent on F, which is what I know. Okay. This, if you are very experienced and not a beginner, you will also identify this with the help of this X marks also. If you see here with the X mark here, it shows that these two activities are interdependent. Okay. You need not even do the multiplication. Without that also you will understand, but if you are new to the whole process, better you do all the steps. So, this I have identified because I have got 1 So, this implies F, G, H, I are in cycle. Now, what am I going to do? I am going to merge the F, G, H, I as 1. You will see here the merging, primarily I wanted to show both the merging together. So, if you see here, since I merged the FGHI into 1, you will see the other relationships are not missed, but this relationships within the FGHI all got damn in the sense they all are not visible. Okay, that is the meaning of showing the merging. So, K gives information to A, that is seen here, A gives information to B, that is also seen, A gives information to F or FGHI, that is also seen here. Okay. Now, F gives information to GHI and G is giving information to FGHI, you need not show because there is no relationships which is done. This you need not even worry. Okay. When you are merging it, just merge both the X marks together, then obviously you will get all the X marks identified. Okay. Now, K is giving information to to F and to GHI, which I have shown it up here. Okay. Now, B is giving information to K, that is also coming here, which is also seen here. Okay. So, all relationships you have to identify, but relationships within the particular activities in the merging you need not show. That is the meaning of what I am saying as merging into one, because you know that there is a block. So, you wanted to keep it as one activity and then start repeating the process. Okay. So, now I am going to repeat the process. So, I have 4 activities right now, A, B, F, G, H, I block and then activity K. Now, when I repeat the topological sorting, what happens? See here, the F, G, H, I block is primarily in the last and the A, B, K has come to the front. Okay. Now, there is a cycle within this A, B, K which you have to identify, because in the further topological sorting what happens? There is no empty row or column. So, obviously, you know that there is a block in the A, B, K. Okay. Again, if you are really experienced with the DSM, you will understand. So, there is a cycle of length 3 here, because I have this pattern here. K gives information to B, A gives information to B, B gives information to K. So, primarily A to B to K, which when you are raising the matrix into power 3, you will get 1 1 1 along the diagonal, you can cross check that later. So, you will identify it as power 3 and when you are raised to power 3 and there is a cycle of length 3. So, now what you have to do, merge this A, B, K as one activity, F, G, H, I as one activity. When you are merging, you are getting a relationship here, okay, during the merging. So, this automatically is topological sorted, okay, otherwise you may have to repeat the process again. Automatically I am having an X mark below the diagonal. So, this implies the matrix is sorted already. Okay. Now, where did we start? We started up on this, the topological sorting process identified you activity D as my first activity, E is my second activity, C and J are my parallel activities in the end. So, start of the project, end of the project I have identified, and there are a lot of activities within the middle, okay, that you wanted to really explore that. For that we have done matrix multiplication. We identified that A, B, K is one block and the F, G, H, I is block is dependent on A, B, K. If you see here, are all the 7 activities in the block has been identified? Yes, I have really done. So, what is the partitioning DSM I am having? So, D, E is my first, A, B, K block is here, F, G, H, I is here, C, J is here. So, this is my sequence, these are the 2 blocks I have got. Okay, so, that is primarily the steps in partitioning. It may look like you have so many steps, but I have explained you the logical meaning behind those steps also. You need not go through all the steps if you are very comfortable in seeing the relationships and working on with DSM. If you are very comfortable in plotting out the relationships on your own, then you can easily identify all the blocks and then plot the X marks. Okay. So, that is all on about the partitioning example. So far we have seen formation of DSM and the partitioning of DSM in the basic DSM operations. Okay. So, I have taken 2 cases, one is formation, one is partitioning. In the next class we will see the next 2 operations in DSM, which is primarily the tearing process, the repartitioning of the tearing processes and the iteration modeling. Okay. Thanks. Bye.